in data analysis with Python. Love to get any thoughts about people's experience to date with Python in the chat here. If there are some complete newbies who have never used it at all, let me know. If there are some people more experienced, let me know. That way I can try and make sure to provide like some tips and tricks that are more kind of intermediate, as well as make sure that I'm just covering like complete basics. Let me just load up a few little bits here for me to share. I'm going to try and go really slowly and just take a minute between each of the steps. Cool. So let's get started. Hi, my name is Max. Who is Max and why is he talking to us today? So I work for MLH. I'm my job is the head of growth. And what that really means is that day to day, I spend all of my time working with tech companies and trying to get them on board to join the MLH community and to get their tech and their organizations in front of all of you. My background is been a total mixture of like tech and business. I studied computer science, started my career as a Python developer, as a Java developer. You'll see pretty quickly that I didn't have a lot of professional experience in Python. About 12 years ago, I did that for a few years and then went into a whole bunch of different things since then. Why am I talking to you about Python and data analysis? Well, after my time as a software engineer, which was only a couple of years, honestly, I ended up doing loads and loads of data analysis, because who knew, in pretty much every job as a software engineer, otherwise you end up analyzing tons of data. For me specifically, I used a lot of Excel for that, because that was just kind of the de facto and the go-to. And over time, I realized that there are better and more exciting things out there. A few years ago, I kind of got back into coding, like taught myself some basic Python, started doing some data analysis, did some data science, actually taught some machine learning classes, did a whole bunch of different stuff in that space. And I found it really, really easy to get up and running with Python and analyzing data. So what I'm going to cover here is just like a bit of an overview, talk you through my experience of the Python kind of ecosystem, a little bit of like why Python and some of the alternatives, dive into a few of the tools that I really like using, actually check some of those out live, and like demo and walk through a little bit of my experience, my ideas. Then gonna hack out a little micro project with a little data set to work through. I think we will also play with a couple of APIs and just do some basics around like grabbing data through an API, grabbing data from a CSV, and doing some of the kind of analysis and crunching on that. We won't have time in this hour to go super deep and to get into every aspect of any of the tools that we cover. And we probably won't have time to get into any of the kind of really advanced stuff around like building comprehensive statistical tests, building out really detailed visualizations, interactive visualizations, machine learning. But what I want to do is kind of signpost where some good places are, and really what I want people to come away from this stream with is like a basic understanding and overview and a sense of where to get started and how to go out and learn and acquire new tools for different projects. I'll take some time at the end to do like a formal Q&A, but what I really want to do is for that to be like almost more of an AMA. Genuinely ask me anything at the end. But as we go, please use the chat as much as you can. The more interaction and questions and feedback we get through the comments here, the better. So don't be shy. I'm just going to drop a little wave in there. and hopefully I'll get some waves back. Awesome. Let me talk you through the journey. So we'll start out just doing some very basic like Python math, I guess, in the terminal. I think it's a funny place to start because a lot of people don't know there's Python hidden in there. Then I want to dive into Replit, which is I think a really cool browser-based collaborative IDE. I think it's a really awesome tool to use at hackathons, especially for kind of ideation as well. We'll pull in a few different libraries, get data from an API, and then we're going to go and dive into Jupyter Notebook. Love to know if people are already using Jupyter Notebooks in the audience here. Talk a little bit about, I think, the Anaconda ecosystem. I find Anaconda Navigator super helpful. Then we'll dive into Pandas. Pandas is one of my favorite Python libraries. I think it is like the godfather of spreadsheets, and you can just do so much more in a few simple lines of code. And not only that, but it scales incredibly well. You can get into like millions and millions of lines of data with no problems at all. And then if we have time, just to jump super quickly into plotting, into doing some charting, just literally some super basic stuff here. But again, like hopefully all of this gives you the frameworks that you need to go and like acquire data, bring them into a variety of different like IDE type environments, start interrogating that data, give you a couple of tools to do that, and then start looking into it, start visualizing it, start exploring it. So let's jump out of this. We will at the end drop back into some slides here. So next, as they say. I always get told off here for having my my terminal too small, so I'm going to just make it really small so it stretches. All right, let's throw the terminal in next and see what happens. All right, that doesn't look too small at all. Awesome. So, like I'm on my Mac here. To get into Python is literally simple. And you're in Python, people. We're coding already. Python is a really interesting programming language because you can do what I would call like imperative coding in it. You can do scripting. You can use it as an object-oriented programming language, and you can also use it just like in a very kind of interpreted, like straight up way. So, for example, we can do 1 + 1. I don't know what that is, which is cool. We can do like a 5 factorial. I see that as well. That's pretty cool. Fractions. Like multiplying fractions together. Let's see if it's got those. Boom. Pretty quick maths. Very, very, very quick. Like it's super efficient in the back end here. All of the algorithms are written out in C, which is why in Python, wherever possible, you should always try and use a library where you can. I'll talk a little bit more about that later on. Okay, let's get into doing some more like weird stuff in here. So if we drop in just like a very basic array, what happens if I try and multiply that by 2? Oh, it kind of works. So Python's a little bit wacky when you start multiplying different kinds of data types together. That was a terrible example because, of course, strings need quote marks around them. If we times hello by 3, we get hello, 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 which is good. Awesome. So you can do maths like straight up in Python. I think that's pretty cool. What I am going to do now is dive is dive out of the terminal, and we are going to jump into REPL. Let me just grab my empty console here. Great. Here we go. Oh, my screen's kind of set up funky. So there's a lot of swiveling around different mouses. I never know if you say mouses or mice. All right. We are going to dive into Replit. So Replit is like the way to quickly get started with like somewhat integrated development environment. I actually think it works kind of more like a kind of a notebook, but basically you get a big run button at the top. Hello Global Hack Week. That's a good start. My hello world works. I always like to start with a hello world. All right. So isn't like 1 + 1 in here? What happens? Nothing. And that's exactly what we're expecting, because in this environment you actually need to print it first. I told you this was going to be basic. There we go. We get 2. That's a good start. So let's take this a little step further and let's start to create some variables and put some values against them. We're gonna just do some like nice geometry here, because that's a great place always to start with doing some data analysis. So we're gonna do a nice print here of height is height. Let me just put a space at the end of this. See what we get to now. We're off to a start. It's a live coding demo and it is not going horribly so far. That's good. Width is, you'll notice that I'm using commas to separate different parts of this out here. I'm just going to stop at width actually, and we can dive in and we can do a little bit more arithmetic in here. I hope this is making people feel like either even they could code and this whole thing isn't so hard, or at the very least that oh, you can't see my screen, damn. Yeah, I was supposed to be sharing a screen. Sorry, folks, I've just been talking away. Here we go. We're all caught up now. We've got the screen sharing on here. Let us do something a little bit more interesting. So all we've done so far is literally just doing some super basic maths, printing out some variables with some strings in front of them, using a comma to concatenate strings and variables. Otherwise, Python gets really upset if you try and add them together. It tries to add the string and the integer together and gets super upset. So we don't want to do that. So let's do something a bit more interesting here. Let's do one of those mathematical operators in here. Length times width. And then we can print area is area. And we're off. We've done computation and we have printed that out. I hope everyone can see my screen now. Shout again, and you're allowed to get angry now if you can't see it. I expect you to be mad. All right, let's do one more of these really boring things in here. Super straightforward. Let's do volume, right, which is length times width times height. Okay. All right. So you can do maths in Python. It works as a calculator. It works as a kind of smart calculator where you can save different numbers as being variables. So basically having a name against the number, and you can add some text around that to make it a little bit more descriptive. I have got a habit of always creating a little loop to print some blank lines, like just because you can. Right, so we get some blank lines. Here's our first library. So Python has tons of libraries. This is why people use Python so much for data analysis, honestly. There are millions. I'm going to say millions. It's probably thousands of different libraries out there that you can use. There's loads that are mathematical and about data processing, about data visualization, and that's kind of the thing that's pushed Python to be the de facto and most used kind of tool for all things data analysis. For a long time, there was a battle between Python and R. Python came from engineering world and R came from academic statistics world, and machine learning happened, which is kind of the intersection of engineering and statistics when you really get to the bottom of it and start thinking about it. When those two things met, there was a battle, and the battle is still ongoing. Lots of people use R, and there's absolutely nothing wrong with it. It's a fantastic tool for a lot of data analysis, but one of the things that really differentiates Python is driving its adoption is that there are tons of libraries. Our first library here is called Math, and it has a whole bunch of more advanced mathematical functions than simply like adding, multiplying, dividing, modulo, powers. I think those are more or less the things that you can do with vanilla Python. So let's just have a quick example. We can ask the math library what pi is. So math.py goes into that library and pulls out the constant pi. And we can then print that, and we can say pi is I. See if that works, and see if we get our nice line spaces between those as well. Awesome. We know what pi is. I think floats in Python 15 characters. Or question about Julia. We'll get back to that. I'm a secret big fan of Julia, having spent a few years working in finance. Julia is pretty cool, very small ecosystem of libraries at the moment. That's probably the thing holding it back, but it is very fast. So like another just very simple bit of like arithmetic just showing how we can use pi, how we can like use this pi. So we can set up like a radius as 3, we can set up a circumference as being 2 pi r. I hope everyone on the stream knows that. And now if we wanted to print out the radius and the circumference with some text around it, we suddenly get into a world where I start to get really upset with putting comma concatenators between things. So we take a slightly different approach here, and we use something called an F string. If anyone has used Python like more than beginner level and not gone into F strings, then that's probably going to be the one thing that you're going to learn today. So an F string is basically a text string. You can use single or double quotes. I switch between them all the time. Call it out if you see it, because it really annoys me, but I just can't help it. And you can use curly braces to put variables in the text, in the string. So conference equals, and then there's loads of other cool features in F strings as well. For example, you can limit a float to 4 decimal places. Before we get into that, I'm just going to do a quick and a dirty print of the whole circumference equals, just so we can check that that is the same and working. So what I've done here with the colon and then 0.4 is capping the number of digits for the circumference float to 4. And we need to close our brackets here. This should be good to go. So let's see what happens. Main thing to notice here is that it prints out exactly as you would hope it would. It gets much cleaner than having lots of commas and quote marks everywhere. You can see in the test where circumference has been calculated, it's to the usual number of many decimal places, and here it's been cut down just to those 4. Love it. Easy peasy. Cool. Time to get into our next library here. I'm going to go back and grab this and put some spaces in here. Super straightforward. Isn't it nice sometimes when you check out a demo and you're like, I got this. All right, so import request. This is for a lot of people, like in the first 5 libraries that they start using in Python. So the way to use requests is basically to handle web requests. We're going to do a get request here, which is request.get. And then I'm just going to grab a URL to an API right here. I'm not going to type it because I will get it wrong. Boom. That's pretty much all we need. What we do need is somewhere for that to go. So we're going to call that response. All right. So just to step through this, we've got a URL to an API. API URLs often start with API dot, but not always. Specifically, this one is pulling back a JSON file. I'll talk a little bit more about JSON files in a moment. Actually, I'm not going to talk too much about them because we're kind of going to avoid them here. But I will tell you a little bit about this API. I definitely recommend checking out opennotify.org. It is all about outer space. It's a bunch of APIs telling you things about space. Specifically, this Astros one, short for astronauts, is telling us about humans in space right now. So we've got we're calling our request library. We're doing a get request, which is pulling a JSON file from this API. I hope that they are no questions there. That all makes a bunch of sense. So what we're going to do with that response is put it into a variable. We're going to call it data because I'm not feeling very imaginative today. And response .json, which is a JSON file that comes down, gets dumped into data, and we are going to print that data out. So hit an API, save as a local variable, print it out. Super straightforward, he says, and then it takes a little worryingly long before it's processed. Okay, here we go. We have got live data from the internet. Looks kind of gross though. I can see loads of different types of brackets, quote marks, colons, and somewhere in there is a bunch of data going on. What I'm going to do is just like show you a thing that I like to do when I get back data like this, which is just to tidy it up. So I've done nothing here but put line breaks in appropriate places to make this a little bit easier to read. So what Python does with JSON files is basically to parse them into dictionaries. There are some ways you can specify how that happens. I don't recommend getting too much into it. For straightforward files, it does a nice straightforward thing like this. So breaking down that API response. This is super typical of a kind of data API. We've got some kind of confirmation that the pull has been successful. That's really useful if you're writing a big piece of code to check whether like the API is up and you successfully downloaded new data. Then we get into the bulk of the data category. So this is identified with people, and it is it's basically an array of dictionaries. So each person has a name, and it specifies which craft they're on. ISS is the International Space Station, and Sheng Chao, hope I'm saying that right, 15 is another shuttle, I believe, that is in space for something like 6 months, about half a year, and then we also get back the total number of people. Especially as when your responses from APIs get bigger than that, it can get pretty difficult to kind of pass through. So I'm going to show you another little trick here, which is to print the keys. So the keys are those like 3 identifiers that you get up here. For the dictionary, which is the message, the people, and the number. So that already helps you to start to decrypt that data coming back. All right, so we have got some data here. Let's do something with it. Let's look at the number of humans currently in space. We can print out the number of humans currently in space is, and then within our data, we're going to pull out number. And using that key is going to pull out the value, which should be 10. Let's hit run here. All right. Number of humans currently in space is 10. Love that. Just going to go through one more quick example of, no, I'm not. I was going to go through another quick example of an API that is also from OpenNotify that gets the position of the International Space Station. What I'm going to do instead is just drop that one in the chat. Boom, 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 boom. If anyone wants to check that out, if you're coding along, give that one a go. You can pull out the latitude and longitude there. There's a little thing about nested dictionaries that you'll have to explore. Great example of you can just Google something. So instead of doing like the code along there, I'm just going to drop that bit of code into this REPL file here. Really just to make one point, which is really, really simple things like the International Space Station is currently at latitude and longitude, blah, 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 starts to get really complicated and messy. And we're not dealing with a lot of data here. It's definitely not big data. It's definitely not super complicated data. We're literally just working with a few numbers and then processing them in a way that allows us to make them kind of human readable. That is the point at which I think we basically need to use some more powerful tools. So I'm going to stop this share here. Just give it a sec for any questions, and we'll go from there. All right. So the next thing that I want to dive into here is a little example of a data analysis in a Jupyter Notebook. I'm going to start from what I would call 0, so assuming not a lot of knowledge and experience of Jupyter Notebooks. If you've worked extensively with Jupyter Notebooks before, you will probably not find this super enlightening. But again, there might be a few little tips and tricks in there that you hadn't thought of before. One thing that I just want to call out quickly before that is Anaconda Navigator. So shout in the chat if you've already used Anaconda Navigator. It works a lot like a package of packages or a library of libraries. It is a software package that contains a whole bunch of different things associated to data analysis. I'm just going to share my screen real quick here and show it. Bam, 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 bam. So this is what Anaconda Navigator looks like. You've got loads of different tools in here and lots of different libraries and environments, which is super helpful. The three things that I think are really useful in here are Jupyter Lab, which is really about kind of building out deeper data analyses. Jupyter Notebooks, which we're going to dive into right now. I'll explain a little bit about what a notebook environment is, how it differs from working just in a straightforward IDE or kind of notepad type program. And the last one was VS Code. I'm sure lots of people here have used VS Code before. VS Code is really interoperable with Jupyter Notebook. And the best thing about Anaconda Navigator is that, one, it installs all the libraries that you'll need in one place, and two is that it links together the same versions of Python for all of these things. Python versioning is a whole bunch of fun in itself. So let me just show that package real quickly. So this is what Anaconda Navigator looks like. There's Jupyter Lab that I mentioned, Jupyter Notebooks, and VS Code. Pretty much just double clicking into Jupyter Notebooks here causes terminal to run a whole bunch of commands, and then in your browser you will get something that looks a little bit like this. So this is Jupyter Notebooks. It's a really cool, if slightly strange, environment. I found it pretty weird when I first got started. I found it quite strange because it's a mixture of Markdown, which looks like this. So this is an example of a Markdown cell. You can see up here that's set to Markdown, and code cells that look like this. One thing to bear in mind is that you have to run each of these cells kind of all the time. So on a Mac, it's Shift Return, Shift Enter, and then that actually processes it. So what we're going to cover here is a quick intro to notebooks, to Jupyter Notebooks, import some CSV data, which is another really classic way of getting data into your kind of first Python programs. We talked about APIs a little bit earlier. This is an example using some CSV data. We will then dive into Pandas, which is another library. We will do a little bit of data cleaning, some very quick analysis, and then a little bit of basic plotting with Matplotlib. And I think that's probably all that we're going to have time for. So a little bit of like orientation and a couple of little tips and tricks in Jupyter Notebooks. So code cells look and feel a lot like any other kind of coding environment, except when you hit enter, kind of nothing happens. There's no like run button. So again, you just keep doing that shift enter. You then get in and out cells. Which is what it is. So again, we can just do something really straightforward, like height equals 5, and if we run that cell, nothing happens. We don't get any output. Let's add in that width equals 10. Still nothing happens. No output. We can then put in that area equals height times width, Still nothing happens. But if we drop area at the bottom, what will happen is the output will default to the thing at the bottom of the cell. If we add average equals height plus width divided by 2, and let's add some brackets because otherwise the division will happen before the addition. In here, so only printing the last thing, so we're not getting both of those. What I can do is print the area and print the average. That's much more helpful, and I can use an F string again, which will make that look a lot nicer. Right, very, very basics. A couple of cool little tricks. When you click on the cell, not in the cell, but on the cell, and you hit A, it adds a cell below. If you hit B, it adds another cell, a cell below it. And you can change, obviously, those cells from code to markdown, to markdown cell, which is not really that different from just putting a comment in a cell, saying empty code cell. Run all of those. Oh, doesn't that look nicer, the markdown cell and the empty code cell? Awesome. So let's get into it. Reading in a CSV. I really like to read in CSVs using Pandas. There are other ways of doing it, but I think Pandas is a really, really good way of doing it. So import Pandas. This is exactly the same using any libraries in Replit or anywhere else. What I recommend doing here, because we're going to be using Pandas a lot, is to give it a name as PD. So PD is our shorthand for Pandas, which is going to be really helpful. I'm also going to add another line in here. I just do this as like a default. Adding that line, percentage matplotlib inline means that your plots come inline rather than opening up as like separate windows, which is super annoying. So we are going to be working with a data set here that is of all of the Titanic passengers. I wonder how many people, when they saw Titanic pandas, thought we would be working with some kind of giant panda here. Unfortunately not, but a really good data set just to explore, like publicly available, lots of different versions of it around, available on just through Google. I think this specific one is from a Kaggle challenge from a few years ago. So setting a variable called Titanic, which we're going to read the data into, pd.read _ CSV is how we read in a CSV file in using Pandas. Now I'm going to intentionally like put an error in here just to show how scary and confusing errors can look in Jupyter notebooks. Okay, and then we have to specify what the separator is in the CSV file. CSV means comma separated values. However, in this version, they are semicolon separated values just for fun. All right, let's hit run. It's not going to work. It's going to yell at us and it's going to make loads of horrible noise. Look at this for an error message. At the top, you get basically an overview of the error, lots and lots and lots of noise about where that's unpacked itself. At the very bottom, you get a slightly more descriptive and slightly more useful error file. That was an intentional error. So hopefully when you get errors in notebooks, you're going to be squirming a little bit less. Let's run that again. Let's run that again and cross our fingers that it's going to work now. Still getting the no such directory error. Let me just dive into that working directory quickly. It's possible that this has opened up in the wrong place. Live coding never works as expected. Let's just hit save here. One thing about Python notebooks, it's a bit old school. You've got to hit save. It looks like it's Google Docs or something like that. But you do always need to hit save. Okay. This should be working. All right, give me 1 second here. I'm going to try and work out what's going on here. Oh, I know what's going on here. I have an ongoing error in my life that 50% of the time I type Titanic. I type Titanic. There you go. Now it's imported. Simple typo. I can't believe that one got me on a live stream. All right, so now we've got our data in. One of my favorite little commands in Pandas is that you can look just at the first 10 lines of data. So this is pretty much what everyone does when they get some data into their Pandas for the first time. Pandas.head. And it's a great way of just looking at a data set. So here we've got like our primary key, our index here, which is always auto-generated. Going to talk more about that shortly. Passenger ID, whether they survived or not. So this is all real data from the actual Titanic boat crash, and their class. The passenger class, or P class, is basically just like what class they're in. So like first class, second class, third class, kind of like a train ticket. Name, sex, age, a couple of other things here. Ticket number, they seem to be really varied, like a real mess. Their fare, so how much they paid, which cabin they're on, lots and lots and lots of empty data there on cabin, and whether they embarked. So yeah, that's pretty much a start on the data. Another thing that a lot of people are going to do as soon as they open up a Jupyter notebook and put some data in with Pandas is to look at what's called the shape. That shows you we've got 12 columns and 891 rows or entries. Next up, I mentioned earlier that the primary key is auto-generated here, so like 0 upwards, but actually that passenger ID looks like it's probably a better thing to use. Tail, exactly the same, last n lines, just like in Linux, exactly. So what we're going to do is we are going to switch over the primary key from the default, which is that auto-generated number, and not necessarily a very helpful one. So what we're going to do is Titanic.set index passenger ID. That's essentially what we're going to do here. So this sets the index, or the primary key, to being the passenger ID column. Everything's very case sensitive in Pandas, so watch out for that. What a lot of people do when they run a command like this is, again, just to chain or add onto the end of it head. So what this is going to do is non-destructively and without changing anything on the data set it's going to set that and then show it in like temporary memory as a variable. So there we go. That looks right. That's what we want to do. So let's grab that command, do it again. But what we're going to do is we're going to add a flag called inplace equals true. Inplace equals true means that it's actually going to apply the change to the whole data set. So let's just, before we do that, go Titanic.head again, spelled correctly. Hasn't actually changed it. So what we need to do is do that inplace equals true, and we can check that has now been pressed as it has. So that's what inplace equals true means. That cell will potentially fail to run if we run it again. So when you're doing in-place operators, it makes sense not to keep running that cell again and again. So one of the next things that we can do is we can take a look at the columns that we have here in our data set. Titanic.columns. Boom, here we go. So we've got survive, P class, name, sex, age, etc., etc., etc. That's pretty cool. And we can look at what data types they are. So that shows you object, integer, object, float, integer. One thing to remember is that a string is a subset of an object in Python. So most of those objects are actually going to be strings. So what we can do now is we can get underneath the Panda, which is like the data frame in Panda, which is like rows and columns, and just grab one of those specific columns and start looking into the data in a little bit more detail. So we can grab a column like name. So when you put square brackets after, it's a little bit like when you're working with an array, you get back the whole column. So let's do that. Here we go, get back the whole column. Another neat thing that you can do in Python is have a look what type something is. So you can see that is a Pandas core series. So Titanic overall, if we look at Titanic overall, that's a data frame. So data frame is basically two-dimensional. It's got columns and rows. Once you select a specific column, it becomes a series. If you select multiple different series, say name and let's go P class. That P class is annoying me already. And then we need two sets of square brackets around it. Don't ask me why. You just do, because you're pulling two columns, which turns it into a data frame again. And we can check that by doing the type. Really useful for debugging. It's a data frame. Who knew? I'm just going to pause there and see if there are any questions. All right. So you build data in a couple of different ways. I think it is time to do a little bit of data cleaning here. So some of these names are really annoying. I'm just going to paste this in here. We can just rename P class as class. Annoying me already to do that. I'm not going to go through that process I mentioned before of chaining head on first and then going in place, because I'm pretty confident that's going to work. We can, we'll see that just by doing a Titanic.head again here. And if you don't put any numbers in, it defaults to 5 rows. I always like to do 10. I don't know why, I just feel better about it. Cool. So another really useful, what I would call descriptive set of statistics is dataframe.describe. Describe. So that shows you for each of the numeric fields, the count, the mean, the standard deviation, the minimum, the percentiles, and the maximum. Super, super useful way of getting a quick view of a data set. So we've renamed class. It looks like one of the most complete records. You see the count is high, so age hasn't got quite complete records. Let's dig into a little bit of data. So Titanic dot class dot value counts. That's just going to pull us back the different values and the number again. So there's 3 different classes: first class, second class, third class, a number of people in each of those. We can also look at the number of unique values. So this is probably less relevant for class, but let's do it for age instead. So that's all of the different ages in here. So there's tons of different ages. Cool. And one of the other things that you'll most definitely want to do at some point is to do a sort. So again, I'm just going to paste this in here. I should go a little bit more quickly. So we're sorting by passenger ID, which is nice. That's a lot of data. I want to take a minute and just say pandas are really frustrating. A lot of the time you're working with pandas is going to feel like this. It is worth persevering because they are crazy powerful once you get into them. I just want to do a real quick bit of data cleaning here, which what I'm going to do is I'm going to convert a data type from, so we look at survived. Survived is yes, no. Where have we got survived? Survived is yes, no. That's not really helpful because kind of a pain to like count and get averages out of. So what we're going to do is set up a little conditional statement: Titanic dot survived number of unique equals 2. All right. I should have called this something else given my difficulties with typing. The word Titanic. So what we're doing here is we're just really simply replacing the yes, no with 1, 0. What I'm going to do is I'm going to get rid of the in place just to demonstrate that again. I knew I typed it wrong somewhere. All right, we've got another message here. Series object has no attribute. I've written number of unique wrong as well. There we go. So if we do, and let's add the in place back in, run that again. What we should be able to see now, which we wouldn't have been able to before, survived. Dot mean, so we'll be able to see the average for the number of people that survived, 38%. That's pretty cool. All right, so there's a whole bunch of exploratory data analysis we could go into from there. I'm just going to grab an example here where we are going to separate out the classes into 3 different variables and then look at the mean of their survival. We should look at that. More people survived in first class, in second class, than third class. That's a pretty interesting little outcome there already. What I want to get into next is age and just show a quick data visualization of that. So Pandas has got Some plotting built in. So hist is histogram. If we take bins 20 out, that we get some plotting straight away, all natively built in. This is showing the distribution of number of people for each different age, which is pretty cool. I'm just going to rattle through a couple of I've just seen that we're at the top of the time here, and I promised a Q&A. All right, I'm going to stop there. So we got into plotting. I'll share all of the info for this at the end of the a little later on today. Let's stop that share and take any questions. I'm just going to give it a minute or so here for anyone to dive in with their questions today. All right, awesome. Well, thanks everyone for tuning in. It's been fun speaking to you. I'm sure I'll be back again soon. Getting beyond some of the super entry level content here in Python for data analysis. Hope you all have a great day and happy hacking.